In this lecture, I am going to implement the k-mean clustering in Microsoft Excel. The algorithm is defined on this slide. In this k-mean clustering algorithm, we have to first initiate the procedure by how many clusters we want to create. So k is the number of clusters. So we have to suggest a value of k. Suppose we want to bifurcate the data into the 3 clusters, then the value of k should be 3. After initiating the number of cluster, we have to suggest manually the k number of means out of the given data points, or randomly we can generate the k points that can be used as a initial cluster means or the cluster centers. So this in the first step, we have to randomly generate k points from the data points, which will be used as a initial cluster centers. Then we have to calculate the distances. That each point distance is to be calculated from the first center. Then we have to calculate the distance of the each data point to the center number 2, and so on. Suppose we have the 3 number of clusters, then distances will be calculated 3 times. Once the distances are calculated of all data points from the center number A, then we have to calculate the distances from all data points to the center B. Then we have to calculate the distances from all data points to the data center C. Then we have to implement all of the data points to any of the cluster, depending if the case number 1 has a smaller distance from center of cluster 1, then we will assign the case number 1 to the cluster number 1. If case number 1, the distance of case number 1 from the cluster B center is smallest, then we have to assign the case number 1 to the cluster number 2, and so on. If the distance of case number 1 from the centroid C is smallest, then we will assign the case number 1 to the third cluster. So this procedure will be implemented and repeatedly will be used. Every time we will calculate the distances and then allocate the each case to any one of the cluster, and then the new cluster mean will be computed, and the procedure will be repeatedly proceeds. So this is the entire procedure, and I want to implement this procedure on this example by Microsoft Excel. In this example, we have 5 data points, A, B, C, D, E, and 2 attributes there are x1 and x2. These 2 data points will be used as a coordinates, x coordinate and a y coordinate. For completing this example in Microsoft Excel, we will use the 2 clusters. The K is 2, and point A and point C are used as the initial cluster means. So A will be the first cluster mean and the C will be the another cluster means. Now in Excel, we will calculate the distance of A to A, then B to A, then C to A, and D to A, and E to A. So these distances will be calculated. Then we again calculate the distances from A to C, B to C, C to C, and C to D, and C to E. We will have the 2 columns of the distances. In the column number 1, we have the distances of all data points from cluster mean A, and in column B, we have distances from all data points to the cluster C. Then we will reallocate that into the either point. Each point will be allocated in either cluster 1 or in cluster number 2. So this procedure will be implemented in Microsoft Excel. You can see these data set. Number of clusters are 2. The using the cluster initial cluster means as A and C. So A is highlighted by the yellow strip and C is highlighted by the red strip. These are the two initial cluster means. And now we will calculate the distances. The distance A from point A. The number of clusters are 2 and point A and C will be used as a cluster means. We will calculate the distance of each data point from the center A. Then we have to calculate the distance from each data point from the cluster center C. So C and A are the two initial cluster means, and we have to use the distance formula. Distance formula is what? Under the root. So we will use the square root SQRT function of Excel. SQRT, and the distances are to be calculated. Y2 minus Y1 divided Y2 minus Y1 whole square plus X2 minus X1 whole square and the root of that. So this formula is to be implemented. So we have to calculate the distance of point A from point A, because we are calculating point A is the center and we are calculating the distance of point A to the point A, that will be 0 actually. So B5 minus B5 whole square and plus, this is basically the x2 minus x1 whole square, then y2 minus y1 whole square. This is y2 minus y1 whole square. And square root of all of this. Square root function is already used. So we should have to create one more bracket because one bracket is missing. That bracket is the bracket of square root function. Now this is the square root function and this is the distance of y2 minus y1 whole square. This is the distance of x2 minus x1 whole square. These two are added. So this is the formula. That distances will be 0, 0 because we are calculating the distance of A from the point A. So the distance y coordinate and x coordinate both will be 0. That is why this distance is 0. Here we are calculating the same distance, but not from A to A. We are calculating the distance from A to C. So I am implementing the formula of A to C here. The same formula can be used. This is SQRT from A minus C whole square plus y2 minus this whole square, and we have some missing brackets here. This is the first bracket that we should have to use. One more bracket, the entire thing will be enclosed in the bracket. This is the brackets of square root function. So this is the distance of point A to the point C. And this is to be copied if we are calculating the distance from point B to the point C, if we are calculating the distance from point C to the point C. But if I am copying this formula So we can see that the distance from C to C is not 0. It means there is some error. What error is there? The error is we should have to freeze the point C. If we are calculating the point distance from point A to the point C, so we should have to freeze the content of C, because whenever I will copy the formula to the rows below that, the address of C will remains constant. So that can be done by some editing in this formula, and that editing is what we have to freeze this B7. So if we want to freeze this B7, so we have to use function F4, because function F4 will basically freeze the content of B7. Mhm. No, $B and $7. Similarly, we have to freeze the content again here. Now the formula is the same value is still there because it will not change to the calculation the point A. But when I will copy this, so this C should be 0. This we have to copy the formula now. Now you can see that the distance from C to C will be 0. The distance from B to C is 2.2. The distance from A to C is 1.4. And if I will copy the formula to the D to E, it's not correct. This is now correct. So this is the distance from the same amendment I should have to do in the first formula, and that is what we have to freeze the content of B5, and here we have to freeze the content of C5. This was the formula that I was editing. Freeze the content of C5. Enter this and copy the formula to the rest of the rows. So these are the distances. This is the distance from A to A. This is the distance from A to B, the distance from A to C, the distance from A to D, and this is the distance from A to point E. So these are the distances. Now, out of these two distances, this is the smallest distance. It means I should have to allocate this point to the cluster number. Point A is allocated to cluster number 1 because the distance is smallest. Point number B is to be allocated to cluster number 1 because out of these two distances, this is the smallest. Now point number C is to be allocated to cluster number 2 because the distance from C to C is the smallest. Similarly, point D will be allocated to cluster number 2 because this is the smallest. And 4.4 and 4.2 point E will be allocated to the cluster number 2. So now the case number A, it is allocated to cluster number 1. It is to the cluster number 1. It is to the cluster number 2, cluster number 2, cluster number 2. Now we have to calculate the mean of new cluster. The mean of these two is to be calculated, and the mean of these two will be calculated. So the x coordinate, the mean of the x coordinate as well as the mean of the y coordinate, these two are to be calculated, and that two means will be used for the calculation of the new distances. Then again, the mean of the second cluster is to be calculated. the mean of x coordinate, or adding all of these three numbers, then divided by 3, adding of all of these three numbers, then divided by 3. This is the way by which the mean will be calculated. So I have implemented all of these things here already in Excel. I am exposing that solution here and erasing these contents which I made here in these 2 or 3 columns. So I am erasing this contents, but I'm exposing the distances first and then erasing it so that we will compare the two solutions. Now you can see that the distances here 0, 1, 1.4, 3 point something, 4.4. These distances are correct. And similarly, we can have the distances from this and second distance, the third distance, the same, and all of the clusters allocation is same. So I can erase this data from the spreadsheet. Now you can see. And implementing this to this and implementing this formatting to all of these cells. Mm. One more thing is now all of these things are fine and the cluster means are to be calculated. These cluster means you can see the formula here. This is the mean of cluster 1. You can see the formula, average formula. This is the formula from the cluster number 1. And this is the mean of the y coordinate of cluster number 1. The mean of these two numbers, 1 plus 0 divided by 2. This is the mean of second one, mean C. The mean can be calculated with the help of mean of these three, and this is the mean of these three. The mean of cluster 1 and the mean of cluster 2 are computed. Then we have to repeat the procedure. How we have to repeat the procedure? We have to calculate the distances again. Now the distance is to be calculated from distance of point A to the mean one, then distance of point B from the mean one, the distance of point C from the mean one, and so on. So this is the way to calculate the distances. And now the distances are again calculated. The same formula is copied. The distance of point A from the mean one, the distance of point B from the mean one, the distance of point 1 from the mean one, and so on. Again, allocation point number C, which was in cluster 2 earlier, now it becomes in cluster number 1. And point number 1 and 2 are again in cluster number 1. And now in cluster number 1, we have 3 points. And in cluster number 2, we have 2 points. Then again, the cluster 1 means has to be computed, the mean of these 3 numbers. You can see how the mean of the again is to be calculated. This mean is the average, and this is the average of B5 to B7. The B5 to B7, you can see B5 to B7, the mean of the first cluster. And then x coordinate. Similarly, the mean of the first cluster, the y coordinate, the mean of second cluster, x coordinate, the mean of second cluster, y coordinate are to be calculated. And after calculating these means, now again the distances are to be calculated. The distance from point A to the mean 1, the distance of point A with the mean 2. So these are, again we have the distances, and you can see the smallest distance is this. The case number 1 is to be allocated to the cluster number 1, point number B to the cluster number 1, and point number D and E are again still in cluster number 2. It means after 2 iterations, we can see that there is no change in the clusters. So we have to stop at the point when the cluster will not be changed. So this is the entire procedure, which is referred to as k-mean clustering. The k-mean clustering, as a conclusion, we can say that it is a unsupervised learning procedure where the class variable is absent, and we have to calculate the distances. On the basis of distances, we have to allocate the data point to the cluster on the basis of cluster centers. Thank you very much for this video.